Hello learners, welcome to the program Postgraduate Diploma in Sustainability Science in course MS-014 Ecological Economics. In previous sessions of this course Ecological Economics, we have looked into the basic concept of economic thoughts and ecology, followed by how the environment economic linkages are there. And then we have looked into the different energy balance principle, that's laws of thermodynamics. So in this session, we are going to look into the broad area of absolute scarcity, means resource scarcity and sustainability from the lens of ecological economics, where we are going to learn about the basic feature of stock flow and of fund service resources and the linkages between thermodynamics and relative or absolute scarcity and sustainability. So before looking into absolute scarcity and sustainability, let us have a quick look into the characterization of various abiotic and abiotic resources, which is very much important when you are trying to look into the absolute resource scarcity and the issues of sustainability. When we are looking along with entropy, there are two additional useful concepts that conventional economic analysis often ignores while they are dealing with the issues of scarce resources. The first concept is, that relates to stock flow and fund service, that given distinction of factors of production. The second concept is about how to describe the excludability in the rivalness of the resources. When we talk about the stock flow resources, that is on the first concept, that stock flow resource is materially transformed into what it produces, while a fund service resources is what suffers wear and tear from production but does not become a part of the output being produced. So the distinction between these two types of resource that can be understood, for example, the timber, for example of timber from the forest. Right, timber from forest is stock flow resources, but the carbon sequestration services given by that forest, that is a fund flow resources. So the distinction between these two types of input is very much important, because the stock flow resources can be stockpiled, like what happened with the wood, but at the same time it cannot be done with respect to the fund service, right? For example, the raw ingredient can be used at any rate to produce the output, but the productivity of the other input is measured in terms of time. So stock flow resource can be used at any rate desired if it is available, whereas in case of fund service resources, it can only be used at a given rate. So a stock flow resource gets used up, but a fund service resource is worn out. And coming to the second concept of excludability and that rival resources. A resource is an excludable resource whose ownership allows the owners to use it while denying others the privilege of using it. In case of rival resource, this is one whose use by one person precludes its use by another person. Analogously, by non-excludability, it is not possible to prevent others consuming the goods once it has been provided to one individual. So non-rivalry implies that an individual consumption of the good has zero opportunity cost, in that it does not reduce the amount of good available for consumption by anyone else. So for this system to work, it must be possible to exclude, otherwise free riding is plausible. One of the classic example of non-excludability is fireworks display. Once lighted, it is not feasible to exclude people in the neighborhood to benefit from the display. So non-rivalry implies that price must be zero, because there is no cost associated with an incremental use. There is no extra cost to the person who has lighted the fireworks if an additional person comes and watches it. The samosa is also one of the examples of excludable and also a rival. If one person consumes a unit of samosa, for another person to benefit from its consumption, a new samosa needs to be prepared at additional cost. So you will see here, we know that whereas abiotic and abiotic scarce resource, they are characterized on the basis of entropy, fund stock flows, excludability, and rival needs. Some of the characterization of abiotic and abiotic scarce resource are shown in this table. You will see here some resources like fossil fuels can be taken. If you look from the characteristic of entropy, they are non-renewable source of low entropy energy, and fossil fuels as stock flow resources that can be excluded when you look from the characters of excludability, and there can be rival needs. In the same way, minerals are non-renewable source of low entropy matter. They are stock flow resource that can be excluded, and rivalness. Okay, they are rivalness. So water, if you look for entropy, there is no entropy value, and then they are context dependent. Whether it has to be stock flow or fund service depends on the context, right? And then that's in same way excludability also, it depends on context. And rivalness depends on context, which you will find out when we study that. We learn that what is stock flow, excludability, rivalness definition. So solar energy in here, ultimate source of that low energy, low entropy energy. It's a fund service resources. It cannot be excluded, and it is not a rivalness. So in the same way, others renewable resources, ecosystem services, water absorptions, the characteristics are given in this table, right? So when we come after have a quick understanding of some of the characteristics of abiotic and biotic resources through the lines of ecological economics, let us come to what is absolute scarcity and sustainability issues. We will see neoclassical environmental and resource economics that focuses on relative scarcity of environmental goods and services, while ecological economics is concerned with addressing the relative and absolute scarcities as imposed by biophysical environment. The belief held by ecological economics is that many environmental goods and services are not only scarce in a relative sense but also in an absolute sense. If we view environmental goods and services as absolutely or relatively scarce, it constitutes one of the basic difference in vision between neoclassical environmental and resource economics and ecological economics. So, from inside of thermodynamic, it established the distinction between this relative and absolute scarcity. So, environmental problems such as global climate change, loss of biological diversity, they can be seen as a problem of absolute scarcity as against the environmental problem of relative scarcity wherein substitution possibilities exist. For instance, if the local pollution increases at their location, one can either shift the production processes to a different location that is green and or undertake measures of pollution abatement. Thus, there is a scope for substitution that was happening in city of Delhi in 20 years back, right? However, in case of carbon dioxide emission, there is virtually no known emission abatement technology. So, how can one find out whether and where environmental goods and services and resources are not substitutable, and whether the needs they just satisfy are elementary or imaginary? Finding this answer of this question requires one to look beyond the limits of economic prosper. Economists have to engage in a dialogue with natural social scientists in order to find out the answer of such kind of questions. Social scientists like psychologists, sociologists, they can teach about how needs emerge, how they are shaped, how they are evolved. So, the natural and engineering scientists can teach what resources are available, how they may be transformed into intermediate or final products, and thus to what extent they may be substituted for each other and for other goods. So, there is need an interdisciplinary dialogue that would allow economists to gain a lot of insight about the domain of validity and limits of economic approach, which is built around the notion of relative scarcity. We learn from the study of thermodynamics within ecological economics, and this is one of the examples of such an interdisciplinary dialogue. In particular, it has become obviously that in to yield insight into irreversible nature, economy, and environment interaction, the first and second laws of thermodynamics needs to be combined in the study of how natural resources are extracted, used in production, and give rise to emission and waste. So such interaction have led to a development of integrated model of ecological economic system. So environmental decision making models can be characterized by a degree to which they are similar to principle known as axiom of material value and axiom of abundance. The axiom of material value holds that resources have no intrinsic value apart from their economic value in markets. Thus, many essential functions of the environment through critical to the economy may have little value because their use is not allocated through markets. In case of the axiom of abundance, it holds that the earth is very large in comparison to the economy, so large that for practical purposes natural capital is unlimited and production need not be limited in the long run. When we say unlimited, that means cannot be significantly depleted or degraded by economic process within a meaningful human time frame. That is what axiom of abundance assumes. So thus, the economic open system would comprise an insignificantly small portion of the surrounding environment and therefore cannot cause its entropy to significantly increase within an economically meaningful span of time. So entropy is then irrelevant to production and thus to the economies. The neoclassical thoughts incorporate constraints on the quantity of natural capital consistent with the first law. However, the quality of man-made and natural capital in terms of how they can substitute for other inputs depend only upon knowledge manifested as technology. Thus, the axiom of abundance changes to an axiom of technological abundance. Means technologies will always be found enabling substitution among sources of natural capital and between man-made and natural capital. So this axiom, if true, means economic expansion can continue without environmental degradation as long as technology discovery continues. And entropy is again irrelevant to the economics of natural resource use. So the economy can expand to those of the surrounding closed system as the economy creates man-made substitutes for environmental functions. So such neoclassical view that predicated sustainability on technological capability can be we said that as a weak sustainability. In this way, ecological economics is a emerging blend of science that deals with both economic and ecological scarcity. And we've seen that ecological scarcity is the result of co-evolution of separate but interacting constraints of economy-environment interaction, ultimately limiting economic growth. So ecological scarcity does limit substitution because the scarcity of one resource may create or exacerbate the scarcity of others. So increased awareness of the considerable uncertainty inherent in predicting the co-evolutionary consequence of economy-environment interaction that has led to the realization that the scarcity of natural resources, then when we trade it in the market, they might not necessarily be correctly perceived or properly valued. So the axiom of material value is rejected in favor of belief that parts of the environment have intrinsic value. Furthermore, if you look into market that focuses on misperceived cause of scarcity, may sometimes produce technologies enabling economic expansion only with new or more severe environmental repercussions. Such perspective classified as strong sustainability, and they unequivocal, they reject the axioms of material value, abundance, technological abundance. And if I summarize what we have learned in this session is, we know that thermodynamics is highly relevant at policy level as it provides an understanding about of which processes do and do not have the potential to meet the energy security and the climate stability goals. While neoclassical environmental and resource economics focuses on relative scarcity of environment goods and services, so ecological economics is concerned with addressing very little absolute scarcity as imposed by the geophysical environment. So with this, let us meet in the next session. Thank you very much.